Hello everyone, my name is Simran. I am from BSc Chemistry on a second year. I am making this video for the visual impaired students. Chapter name is Nitro Compounds. Introduction. Nitro compounds are an important class of organic compounds which may be regarded as derived from hydrocarbons by the replacement of one or more hydrogen atoms by nitro groups. Nitroarenes can be prepared rather easily and have been used as synthetic reagent since long. But nowadays, even nitroalkanes are being prepared and used on a large scale. Structure of nitro groups. Nitro groups is quite often represented as containing a double bond between nitrogen and one oxygen and a coordinate or dative bond between nitrogen and other oxygen or but actually nitro group is stabilized by resonance and is hybridized by of two equivalent contributing structures. The resonance hybrid structures is confirmed by the fact that the bond length of each nitrogen oxygen bond is 1 to 1 pm or 1.21 angstrom, which is intermediate between NO single bond length and N double bond O bond length. In case of nitroarenes, resonance of nitro group with the ring can also take place, giving rise to additional contributing structures for the molecule. Nomenclature of nitro compounds. Nitro compounds are named by writing the word nitro before the name of the parent compound. The number of nitro groups and their position are also suitably indicated as illustrated below. Classification of nitroalkanes. Nitroalkanes are termed as primary, secondary or tertiary according as the nitro group is attached to a primary, secondary or tertiary carbon atom. Preparation of nitro compounds. Preparation of nitroalkenes. Nitroalkenes are usually prepared by the following methods. First, vapor phase nitration of alkenes. This reaction involves the substitution of a hydrogen atom of the alkene by a nitro group. It is carried out in the vapor state by heating the alkanes with nitric acid at about 700 Kelvin. Limitations of the process. During nitration of higher alkanes, all possible isomeric nitro products are formed. Moreover, rupture of carbon-carbon bond also take place, leading to the formation of nitroalkanes containing lesser number of carbon atoms. For example, nitration of propane results in the formation of a mixture of 4 nitro compounds as shown below. Due to the formation of complex mixture of products, this method is not used for the laboratory preparation of nitroalkanes. However, the method is widely used for the commercial preparation of nitroalkanes. Mechanism. The reaction is believed to involve the formation of free radical, but the mechanism is not well established. Second, action of silver nitrate on alkyl halides. This is the method generally involved for the laboratory preparation of nitroalkanes. When heated with silver nitrate, alkyl halides undergoes a nucleophilic substitution to form nitroalkanes along with small quantity of alkyl nitrates. This is because NO2 negative is an ambient nucleophile. However, the mixture of alkyl nitrates and nitroalkanes can be separated by fractional distillation. Oxidation of amines. When an amine in which the amino group is attached to a tertiary carbon atom is oxidized with potassium permanganate, a tertiary nitroalkene is obtained. Preparation of nitroarenes. Nitroarenes are almost invariably prepared by direct nitration of arenes. The nitrating agent generally used are: first, concentration of fuming nitric acid. Second, mixture of concentrated of fuming nitric acid and concentration sulfuric acid. This mixture is the most commonly used as nitrating agent. Mixture of concentrated nitric acid Anesthetic anhydride or boron trifluoride. Acetyl nitrate obtained by mixing nitrogen pentoxide and acetic anhydride. Nitrogen peroxide in the presence of anhydride aluminum chloride. Choice of a nitrating agent. The choice of nitrating agent to be used for nitrations of a given compound depends upon the following two factors. First, nature of compound to be nitrated. Second, number of nitro groups to be introduced. In the nitration of aromatic compounds contain electron releasing or activating groups such as NH2OH and CH3, the reactions take place readily at room temperature by by concentration HNO3. In some cases, even dilute HNO3 can be used. For nitrating compounds containing electron attracting or deactivating groups such as COOH, or when it is derived to introduce more than one nitro group, a suitably strong nitrating mixture has to be involved and the reaction is carried out at high temperature. Nitrobenzene and M-dinitrobenzene, for instance, can be obtained from benzene under the conditions shown below. Mechanism of nitration. Nitration of aromatic compounds, like other aromatic substitution reaction, is electrophilically in nature and involves a nitronium ion NO2 positive as the attacking electrophile. The mechanism may be summed up as follows by considering the nitration of benzene with nitric acid sulfuric acid mixture. Evidences in favor of the above mechanism. It has been shown above that aromatic nitration involves a step-wise mechanism. The nitronium ion, which acts as the electrophilic reagent, is generated in a preliminary step and brings about further reactions in two steps. The first step is a slow rate determining step, involves the addition of nitronium ion to the aromatic ring to form a carbocation intermediate. The second step, which is relatively fast, involves the elimination of a proton from the intermediate ion by the heterolytic cleavage of CH bond. This mechanism has been fully supported by isotopic tracer technique as explained below. If an aromatic compound labeled with deuterium is subjected to nitration, it is found that the rate of substitution of deuterium is the same as of the ordinary hydrogen or plutonium. In other words, no isotopic effect is observed. Chemical reactions of nitroalkenes. The important chemical reactions of nitroalkenes are: first, acidic nature, tautomerism. Nitroalkenes contains alpha hydrogen atoms, exhibit acidic behavior and form salts in the presence of strong alkenes. Acidity can be attributed to the fact that first, nitro group has a strong electron withdrawing inductive effect. Second, anionic formed after the removal of a proton from nitroalkenes get resonance stabilized due to the ability of the nitro group to accommodate negative charge as shown below. It is interesting to note that if the salt formed by the nitroalkenes is acidified at low temperature, the oily drops of nitroalkenes do not separate immediately, but we get another form of nitroalkenes known as acinitro forms, which slowly change into the nitro forms. Selective reduction. In case of compounds containing more than one nitro group, it is possible to carry out the selective reduction of one of the group by employing a mild reducing agent, such as ammonium hydrosulfide or sodium polysulfide Na2SX. Third, electrophilic substitution. Nitro groups being an electron withdrawing group has a strong deactivating effect on electrophilic substitution reaction of benzene nucleus. However, under strong conditions, nitro compounds may undergo electrophilic substitution in meta position with respect to the nitro group. Nucleophilic substitution. The nitro group has no doubt a deactivating influence on electrophilic substitution in a benzene nucleus due to its electron withdrawing nature. But this very electron withdrawing influence of the nitro group makes the benzene nucleus liable to be attacked by electrophilic reagent. Thank you.